The height h in feet of a golf ball after t seconds is given by h equals negative 16t squared plus 96t. How long does it take for the golf ball to reach 128 feet? Also, how long does it take to reach 144 feet and then the ground? Whenever we're given a formula or a function and we have two variables, in order for us to solve for one, they have to give us information about the other variable. And so we want to look at the information given as well as what the variables represent. So one of our variables is h, which represents height, and our other variable is t, which in seconds, which represents time. And so looking at the information given, how long does it take? That's saying solve for time. Solve for time. So we're solving for t. For the golf ball to reach 128 feet. Well, that's as a height. So they told us what to use for h. And so what we're going to go ahead and do is take 128 feet and we're going to substitute it in for h. So 128 equals negative 16t squared plus 96t. And so now that we have an equation with only one variable, we can go ahead and do our first step, which is set it in standard form. So we'll go ahead and get standard form. Standard form, if we add 16t squared, and subtract 96t, and then keep the 128 so that we have it set equal to 0, and then we can factor. So step 2 is factor, and here we do have a GCF, so we can actually factor out 16 first, and then that's going to leave us with 6t plus 8 equals 0, and then we can continue to factor it. So a product of 8 but a sum of negative 6, that's going to be a negative 4 and a negative 2. So it factors to be t minus 4 and t minus 2. Now we can do our next step, which is 0 factor property. 0 factor property says take each factor with a variable and set it equal to 0. Well, 16 doesn't have a variable, so we don't need to set it equal to 0. T minus 4 has a variable. T minus 2 has a variable. And then we can go ahead and solve both of those. So we get t equals 4 and t equals 2. So we actually have two values for time. And so we want to make sure and see if both of those are reasonable. Well, if we have a golf ball and we hit the golf ball, okay, hit that golf ball, it's going to go up, and then eventually gravity is going to kick in, it's going to hit again, and it's going to come back down. And so what that means is at 2 seconds, the ball reached the desired height, and then on its way back down, it also hit that same height again at 4 seconds. So now we know that both of those are valid answers. So t equals 4 and t equals 2. 2 seconds and 4 seconds. Let's go ahead and answer the next part of the question. Let's change our colors up here. All right, so now we want to know, well, what is this 144 feet? So now we're going to plug in 144 for h. And so we try to change 128 to 144. We're actually going to end up with the same equation except for the constant will be 144 instead of 128. So we can go ahead and just skip to that step because that's the only thing that's going to be different. We'll have 144 instead equals 0. And then we can go ahead and factor out a GCF of 16 again. And we actually have a perfect square trinomial. And so t squared minus 6t plus 9 factors to be t minus 3 squared. And so again, we'll set each factor equal to 0. Well, 16 doesn't have a variable, so we don't need to set it equal to 0. T minus 3 has a variable, so we can set that equal to 0. And we have another t minus 3 because it's squared, but it's going to give us the same answer, so we don't need to bother writing it twice. and so we can solve and get t equals 3. So this time we only have one solution at time 3. And let's think about that again, the trajectory of our ball. For all of these times along the curve, we're going to be at a height twice, except for this one particular time when we reach the maximum height at 3 seconds. So we need to consider that as well, and be aware and kind of interpret that answer, that the ball reached a maximum height of 3 seconds because it was only at that height one time. Let's change our color one more time and answer the last question, the ground. Again, in order to solve this, they have to give us some information about the height or the time, and the ground implies something about the height. It implies a height of 0. And so this time, we'll take our equation and we'll set our height to 0. Again, same equation, but now we have a constant of 0. Instead of 144 or 128, the height was 0. And so we can actually factor this a little bit more simply. We can get rid of that constant, we don't need it. And we can factor out our GCF again, but this time our GCF isn't going to be just 16, it's going to be 16t. And that's going to leave us with t minus 6. And so then we have two factors. We have 16t equals 0 and t minus 6 equals 0. When we solve both of those, divide by 16 or add 6, t equals 0 and t equals 6. Well, t equals 0 is where the ball started. Started on the ground at 0. Time equals 0. And then time equals 6 seconds. That's when the ball landed, which is where the ground is. So our final answer would just be time equals 6. Now we have the product of two consecutive positive integers is 132. We want to find those two integers. Product means multiplication. Consecutive means one number after another. So we're just going to add 1 to get consecutive. Positive means that our answer has to be positive. And integers means no decimals or fractions. No decimals or fractions. So we need to consider that when we're looking at our solutions to make sure that we don't pick any negative numbers, we don't pick any decimals, we don't pick any fractions. So we can write an equation. So we're going to have our first number times our second number, and that has to equal 132. Well, our first number we can just use as x. We don't know what our first number is. But our second number has to be consecutive to the first. And consecutive means we're going to add 1 to it. So our second number is going to be our first number plus 1. Our second number is our first number plus 1. And that product is 132. Now that we have our equation in one variable, we can go ahead and get it in standard form, which means we'll distribute. And we'll subtract 132. So to factor it, a product of negative 132 with a sum of 1 is going to be 12 and negative 11. Now that it's factored, our zero factor property we get two possible answers. Two possible answers for the first number. We get two possible answers for the first number. We get the first number can be negative 12, or the first number can be 11. But now we have to go back to our original problem and remember, it says our answer has to be positive integers. Well, negative 12 isn't positive, so we can't use negative 12. So our first number has to be 11, and then our second number will be our first number plus 1. So 11 plus 1 is 12. So the two numbers are 11, and 12. Let's do a quick review of our Pythagorean theorem. We know in a right triangle the sum of the squares of the lengths of two legs is equal to the square of the length of the hypotenuse. And so you hopefully recognize our formula, a squared plus b squared equals c squared. It's just really important that our hypotenuse is c. Which leg is a and which leg is b does not matter, but c has to be the hypotenuse. So we want to find the length of the shorter leg of a right triangle if the longer leg is 10 miles more than the shorter leg and the hypotenuse is 10 miles less than twice the shorter leg. And so we're going to kind of take a look at these things. So we have our shorter leg, which we don't know, and we know that the longer leg is 10 miles more than the shorter. So we'll take our shorter leg and we'll add 10 miles. And we know that the hypotenuse is 10 miles less than twice the shorter leg. Twice is 2 times. So we're going to take our shorter leg, multiply it by 2, and then we'll subtract, and that'll give us our hypotenuse. So that's C, and that's B. So now we can use our Pythagorean theorem. A squared plus b squared equals c squared. We'll plug in the values that we have to represent each of those sides. And then we need to get it in standard form. First thing we'll want to do is expand it. So a squared. If we use our perfect square trinomial formula, we know that the sum of two terms squared is going to be the first term squared, double the product of 2, and then the last term squared. And so we expanded that out. If you want to do it the long way, you could take a plus 10 times a plus 10 and just distribute it all the way through, and that will give you that same answer. And then we can use the same process with the other side of our equation. So we get 4a squared minus 40a plus 100. And then we want to group everything to one side of the equation. So I'm going to move everything to the right since that has the larger coefficient as positive. I don't want to leave it as positive. So we'll subtract 100 from both sides. Those will cancel. This is 2a squared. So we'll subtract 2a squared from both sides. And then we'll subtract 20a as well from both sides. So we get 0 equals 2a squared minus 60a, and then that cancels out to be 0. And so we can go ahead and factor. Well, we have a GCF of 2a, and we're left with a minus 30. Zero factor property says let's set both of these equal to 0. And we solve. We get a equals 0 and a equals 30. So again, we have two possible answers. Let's check them to see if they work. Well, if a equals 0, well, that gives me a side length of 0, and that also gives me a hypotenuse with a length of negative 10. Well, we know that can't work, because that gives us a equals 0, b equals 10, and c equals negative 10. Well, mathematically, with our Pythagorean theorem, that may work out, but within our triangle, we cannot have a side length of 0 or a hypotenuse of negative 10. So we know that that one's not going to work. So a equals 30. Well, a equals 30, and then b equals 40, and then c equals 50. Well, yeah, that's going to work out for us. And so we know that a can be 30 miles. Last thing I want to tie in here is our solutions to a polynomial equation are the x-intercepts of the graph of the related function and the x-intercepts of the graph of a polynomial function are the solutions of the related polynomial equation. We also call these values roots or zeros of the polynomial. And so what we're saying here is that when we take our quadratic or any polynomial in standard form and we set it equal to 0, what we're doing is finding actually the y-intercepts, or I'm sorry, the x-intercepts of a polynomial equation when y equals 0. That's the definition of x-intercepts. And so when we're solving these polynomials, we're finding the x-intercepts of our graph. We'll actually be able to tie that in with something we learned earlier in the year to look at our polynomials even more closely. So given f of x, we want to match each function with its graph. Given f of x, we see that we have 1, 2, 3 factors, which means we have 3 solutions. And by what we just talked about, that means we also have 3 x-intercepts. And since we have 3 x-intercepts, we can actually kind of narrow this down. We know that A is not going to be an option because it has 2 x-intercepts. So our answer has to be B or C. And so we just need to compare and see which one has the correct x-intercepts. And so we'll take our equation, set it equal to 0, and then we'll solve for each of those. If x equals 0, x plus 3 equals 0, x minus 3 equals 0, we get x values of -3, 3, and 0. And so we have intercepts of 0, 0, -3, 0, and 3, 0. Well, the graph that has all of those is graph B, -3, 0, 0, 0, and 3, 0. So we know that f of x is going to be B, f of x. All right, do the same thing. We look at the next one, and again, we apply our zero factor property and set all of those equal to 0. We get -3, 3, and 1, meaning we have intercepts of -3, 0, 3, 0, and 1, 0. Again, I have 3 intercepts, so it can't be A. Process of elimination tells me it has to be B, but we can just double check our work here and see that we do have -3, 1, and 3 as our x-intercepts, so we know that C is going to be G of x. C is going to be G of x. And then lastly, again, process of elimination, we're left with H of x. 2 factors means 2 intercepts. We have an intercept where x equals -3 and x equals 1. -3, 0, and 1, 0. We can see that here on the graph, we only have 2 intercepts. And so those are listed. H of x is A. H of x is A. Now to tie in something earlier in the year. Earlier in the year we talked about end behavior. Okay, so end behavior said that if we had a positive polynomial, so if f of x was a positive ax to whatever value, let's say ax at any degree polynomial, then we're going to go up in our end behavior, depending on whether we have the parabolic shape or that sideways S shape. And if we have a negative polynomial, then that means that our parabola is going to open down as well as that sideways S shape is going to go down. And that parabola and that S shape is based on whether we have an even or odd number of factors. So let's say we take f of x and we make it negative. So we go back to f of x and we have negative x, x plus 3, x minus 3. I still have the same zeros where x equals 0, x equals -3, and x equals +3. But instead of our graph looking like B that we have here, it's actually going to be flipped upside down. And it's going to go this way, and then back up, and then end going in the downward direction. And so if we have that negative leading coefficient, we end up with this graph with the opposite end behavior. That opposite end behavior. If we have our quadratic h of x, and we make it negative x plus 3, x minus 1. Again, we still have the same roots, but now we're going in the negative direction for negative h of x, that negative end behavior. So we're able to pull in some of that prior information, and now we can apply end behavior as well as solutions in order to identify and graph polynomial equations.